We're going to go ahead and take a look at simplifying expressions that have exponents. Now, we want to go ahead and review kind of what exponents mean. So if I have something like a to the fourth, that means I'm going to take a and multiply it together 4 times. So like 5 to the third power, or 5 cubed, is going to be a 5 times a 5 times a 5, which you could work out to be 125. When I look at negative 1/3 all cubed, that's a negative 1/3 times a negative 1/3 times a negative 1/3. So the exponent kind of tells you how many times you're multiplying that number together by itself. And so we multiply the tops, we multiply the bottoms, because that's how we multiply exponents, and we get negative 1 over 27. So negative 1/3 to the fourth means it's negative 1/3 multiplied together 4 times. Once again, multiply the tops, you get a positive 1, multiply the bottoms, you get 81. By the way, 81 because it had more points than 79, so that's why 81. So, do these two things equal each other? Well, the right side would be a negative 1/3 times a negative 1/3, which we know is positive 9. The left side, the exponent does not apply to the negative. The exponent only applies to the 3. So we're going to leave that negative in front and then just have 3 times 3. Well, that means we end up getting negative 9. So are these equal? No. So be paying attention whether the negative is in the parentheses with the exponent applying to it, or whether it's not in parentheses, because it makes a difference. Also, anything to the 0 power is going to be 1, with the exception of 0 to the 0, which is undefined or indeterminate, and that's something that you'll end up dealing with in calculus. But for the most part, just remember anything to the 0 power in your class will end up being 1. Now, when we're looking at 2 times 3 to the 4th power, is that going to be what we have here, or is that going to be this here? In other words, do we have to work out the 3 to the 4th first, or do we go ahead and do the multiplication first and get the 6, and then deal with the exponent? Now remember in PEMDAS, you always have to do exponents first. So it should be a 2 times 3 to the 4th. 3 to the 4th is what we did right here, and that's 81. So it should just be 2 times 81, or 162. That's what it should be. It is not this. You always have to do the exponents first. So are these, does this equal this, or does this equal this? It equals the 162. Also, to help refresh your memory, when you're dealing with a negative exponent, that means you need to take the reciprocal or move it to the other part of the fraction. Here, this is over 1. Just a second here. It's over 1. So basically, you have to move this exponent and the a to the other part of the fraction so it moves to the bottom. Or you can also think of it as taking the reciprocal, meaning flipping the fraction upside down. So when we have 5 to the negative 2, that really means 5 to the 2 is on the bottom, so it's 1 over 5 squared, which we know if we work out the bottom would be 1 over 25. If your negative exponent's on the bottom, it gets moved to the top. And so then we would just get 8 cubed over 1. And if you wanted, you could go ahead and work that out. But that's kind of a quick review of exponents. Now, when you have 5 squared times 5 cubed, some of you might be thinking, okay, is this where we add exponents, or is this where we subtract exponents or multiply exponents? Well, let's think about what this means. 5 squared means 5 times 5. Now, the 5 cubed means 5 times 5 times 5. So with that in mind, you can see that we have 2 of the 5's here, 3 more of the 5's here, so that's a total of 5 of the 5's. So your exponent's 5. So how do you get that exponent of 5 from your 2 and 3? You get that from adding. I would encourage you not to just go ahead and try to memorize these rules, but to really think about what these exponents mean. Because then even if you forget the rules, you'll still be able to go ahead and work this out. Now, a 2 to the fourth all cubed means that 2 to the fourth is going to show up 3 times. So you're going to have a 2 to the fourth, 2 to the fourth, a 2 to the fourth. Now that kind of takes us back to what we were doing here. We have 2 to a power times 2 to a power times 2 to a power. Basically what we set up here was when you have that situation, you add your exponents, so you get 12. So you might think, what do I do with the 3 and the 4 to be able to get that exponent of 12? And you multiply it. Once again, if you're not sure on the rule, always go back to what the exponents mean, and you'll be able to work it out and get the right answer. So 2 to the fifth is 2 multiplied 5 times. 2 squared is being 2 multiplied twice. Now 2 over 2 is a special form of 1. 2 over 2 is a special form of 1. So these 2's can cross out, leaving us only with these 3 2's here, which is really a 2 cubed. Some of you will think, oh yeah, that's when I subtract my exponents. Well, yes, that's true. Another way you can think of this one here is which one has more 2's, the top or the bottom. Most of you will say the top because it's 5, and I'll say how many more. And well, 5 is 3 more than 2 for your exponents, and so that's why you get this one here. So as you look down here, we have a 2 to the x all cubed. So that means it's going to be 2x, 2x, and 2x because it's 3 times showing up, which really means it's 2 multiplied together 3 times and x multiplied together 3 times. So you could write it as a 2 cubed and an x cubed. So when it's multiplication or division really on the inside, you can take your exponent and apply it to each one. Now, remember we had said earlier with negative exponents, you need to go ahead and do the reciprocal or move it to the other part of the fraction. So this 2 to the negative 5 moves to the bottom part of the fraction. The 2 or 3 to the negative 2 moves to the top part. And when you move it, your exponent becomes positive. Similarly over here, you move the a to the negative m to the bottom, b to the negative n to the top. If the whole thing has a negative exponent, you can just flip the whole fraction upside down and then leave your exponent. And that's what this is saying right here.